Welcome. I'll be talking about scheduling in a computer system. But first, what is scheduling? It is the use of a set of rules to determine the order that jobs should be handled. 4 goals of scheduling algorithms include to make efficient use of processor time, to make efficient use of resources, to maximize the number of users without apparent delay, to maximize the throughput of the CPU. The scheduling algorithm should also ensure all tasks are processed by changing the priorities if necessary. The purpose of scheduling is that users get fair access, ensures there is a reasonable response time for all, ensures algorithm is robust so that a system will not fail through overloading or by becoming blocked. Why do operating systems use it? To ensure all tasks are processed by changing priorities when necessary. It processes as many jobs as possible in the least possible time. How many things can it do at once, basically? And another thing is that it maximizes the number of interactive users by receiving a fast response time. So, an example would be, just saying like no time thing. So it needs to be a fast response time. Is that if someone's like printing something, you don't just want it to be like, oh, let's just let just one person have it and they can just print off theirs and just let everyone wait. But then that is getting into the type. Right then, so there are actually different types of scheduling algorithms. I'll be going through them, so I state what it is and then I state the features of them. So the round robin is that every user gets a small amount of time with the processor before it goes to the next user. It is used in a multi-access OS. It uses time slices of various lengths to ensure all jobs get a share of the processor time. It can be even for a few milliseconds. After the time is up, the processor moves on to the next task. Now, the shortest job first involves when new jobs are added. It is important to make sure that they are placed in the right place in the queue by the by the operating system making an estimate of length of time required to carry out task. Although this leads to a lot of jobs being done quickly, it can also lead to some longer jobs never being processed. So, for instance, if someone's printing out something, say if someone new comes into the room and they decide to print something, but say if you've got something and if you've got 100 pages or something, you're going to print that off. But then someone else comes in and they send something to print off, so it's like 2 pages long, and then that gets printed off, and you're just waiting. And say if another person comes in, you just keep waiting. Alright then, so yeah, that is the shortest job time. The shortest job first, but then the shortest remaining time is similar to shortest job first, being that it makes an estimate of the length of time required to carry out the task, but the jobs get shorter and hence nearing to the top of the queue, so they are processed. Jobs returned to queue when jobs return to the queue when some reason such as keyboard or input required. So a job is returned to the queue if like an interrupt gets done. So say if it prompts you, if you're printing something out and it runs out of ink, say running low on ink or something, it sends an interrupt to the actual. You can send it to your computer through the cable and you can get a notification on the screen, or it can actually do it on the printer itself. So you just get the I need more ink thing and it stops all processes, because you don't exactly want to print with no ink, because then you can't print with no ink. Other things are that although this is actually considered slightly superior because longer jobs will slowly bubble up until they have the shortest time remaining. But still, it's just probably not really that best one to do. Probably the best one will probably just be the round robin, since everyone gets a chance to use a small amount of time to do it. And then there's the first come first serve, which I think most printers actually already do, where the first job is just ready for processing is processed, so that would work just like a queue. It'd just be a queue. So one person, then you get another person, and the first person that was there, they get done. Their thing gets done, then they get removed from the queue, and then you do it like that. So another type of scheduling is the multi-level feedback queues. It is a number of queues are set up. If a task actively uses large amounts of processing time, it is placed in a lower priority queue until it reaches the base queue, which operates in a round-robin fashion. Although this type of scheduling is very complex, it involves number of queues to be set up according to file and acting like a set of league tables. Jobs given lots of peripheral time, they drop down the table, some getting relegated when jobs finish, they leave the system, and another job can be promoted. Jobs cannot spend much time monopolishing the processor, so that's like using up the processor's time, so it cannot spend much time using the processor also. So anyways, hopefully this has been helpful for you, so thanks for watching. The next video is on memory management.